equations is that I think that it winds up being a little bit easier than what we did yesterday. And the reason why that is because you're no longer really, you still have to worry about your denominators, but since we have an equal sign, you're able to eliminate them. And it makes for a little bit smoother ride through some of these problems. So what I want to do here is just kind of jump right into how you set something up to solve a rational equation, which basically means fractional equations. And if I'm looking at something where it's just x over 3 plus x over 4 equals 7 over 4. I appreciate you waiting out on that. Excuse me. When I do that, I need to get a common denominator to be able to do that addition part. But better still, if I think of something, or I can figure out something to multiply both sides of an equation by, I can get rid of the denominators and make my life even easier. So what I do here is I look for the common denominator of all three parts. So what's the common denominator of 3 and a 4? 12. So if I multiply everything by 12, I'm going to do this longhand a couple of times so you can get the idea of what it looks like prior to shortcutting. You wind up with this: 12x over 3 plus 12x over 4 equals 12 times 7 over 4. Because I'm multiplying, when I'm multiplying a fraction to a whole number, I'm just multiplying numerators. This is 12 over 1. Okay. It's different when you're working with equations, because what we're doing now is, since we're keeping things balanced, as long as you do something to one side, you do it to the other, as opposed to multiplying by a factor of 1 straight through. Okay, that's the difference. Now, does everybody see how I'm going to be able to simplify each one of those fractions relatively easily? What's 12 over 4? Or over 3? 4. So this first one becomes 4x. The next one becomes 3x. What's 4?
21.
What's 12 divided by 4? What's 3 times 7?
21.
Blackjack! You get 3. Okay. By multiplying straight across with the common denominator, as long as you're doing that to both sides of the equation, everything stays valid, because, you know, numbers are jealous. What you do to one side, you have to do to the other. In doing that, you're eliminating the denominators, and it winds up being a very easy two-step problem. What?
Numbers are jealous, that's why you gotta find their x.
That's why. I like that one.
Wait, can you say that?
Numbers are jealous, that's why you gotta find their x. That's good. That's good. I like that. You're all proud. You're proud of yourself. That's a good one. I like that one. You should write that on the window.
When you divide a pumpkin circumference by its diameter?
Pumpkin pie.
Why is I over 8?
Yeah.
I over 8 is hilarious.
It's not funny at all. It's the worst joke I've heard.
All right, let's try another one.
Oh, now I get it. Like the I over 8. The square root of negative.
I get it.
Man, you're awesome. In this case here, I have x over 3 minus x plus 2 over 5 all equals 2. Over 1, good. So it's 2 over 1. I want to multiply both sides of this equation, correct, to get rid of the fractions. You multiply everything by 15. Okay. Once again, I'm going to multiply this out long form before I start shortcutting. 15x over 3 minus 15 times the quantity x plus 2 over 5 equals 15 times 2. You okay with that so far?
Yes.
Start simplifying our fractions. We have 5x minus 3 times the quantity x plus 2 equals 30. Yes, ma'am?
So you don't want to distribute for 15 at a time?
No. You want, see what I'm doing here is I'm setting this up, I'm distributing the 15 to all three, to everything, and then I'm going to simplify first.
Okay.
Okay.
Simplify first.
Yep. Simplify first.
And then you distribute.
Okay. Not as bad as you were probably thinking, were you?
Is it okay if you do like multiply out and then do it?
It can be necessary real fast because then you have 15x plus 30.
Just outline. I know that was easy.
I'd surprise, I mean, I'm going to really, real quickly here, shortcut some stuff, and you'll see why it's a little bit easier. It's a little thinner.
For the record, that's only the second time I've done it all year.
All right. Now, I have 3x plus x over 3 equals 5. What am I going to multiply everything by? 3. Multiply everything by 3. So you have 9x plus x is 15. Well, we're going to start shortcut. Distribute the 3 to everything. You get 3 over 3, which is 1. 3 times 3 is 9. 5 times 3 is 15. I'm just doing some shortcuts. Get 3 over 2. Okay. No.
Yeah, until you have to like graph it.
I'm not graphing this.
There's no
That's
graph.
funny, they're actually
They're complex
fractions.
Or they're negative.
I would say having the graph it would be
So, one quick reminder, for some reason, your book and a lot of text, they put the negative symbol even with the fraction bar. I recommend when you're doing stuff like this, move the negative symbol to the numerator. It's a little bit cleaner. People tend to see it better then. He's got it over here.
Wait, I have a question, like not math related.
1 second. Yes, ma'am.
If you had like 4x, 4 over x minus 2 over 5, could you flip it and have 2 plus n?
No. What's up?
Always love everything I know. I'll give you a calculator that's gonna be like, I give you that, I give you that.
Okay. Anyway, now, common denominator. What do you have to multiply everything by? 2x. Well, what's going to be the common denominator? Least common denominator among everything. So here's what happens, guys. If I multiply everything by 2x, I'm going to start short. Yeah.
2x because there's like the 2 in that.
You're looking for the least common denominator. The least amount they can have in common is the 2 and the x. So here's where it comes into play with a little bit of this shortcutting again. It mirrors a little bit of the idea of what we were doing yesterday with the adding and subtracting by who has what within each fraction. For example, in this first fraction, the 4 over x, it already has the x, but what does it need?
2.
What's 2 times 4?
8.
The next fraction already has the 2, but what does it need?
Or you could just do it the long way.
Yeah.
Or you can do it the long way.
Yeah,
It's
I
I
do it
do
the long
it
way
better.
because I don't understand.
It's fine. Then the last one it needs what?
2.
The 2. Long way. You have 2x times 4 over x plus 2x times 5 over 2 equals 2x times negative 11 all over x. Going the long way, you just have to start simplifying.
But I don't understand, like, how do you get rid of the denominator in the first one? Like, how did it just disappear?
What's x divided by x?
Wait, you're just, what?
Look here. I multiply everything by something, and I get x divided by x.
No, but for the first one.
Right. What's the common denominator? 2x. If I multiply everything by 2x, I get 2x times 4 over x. Those x's go away. That's the whole point. You're trying to get rid of your denominators. Okay? So now, subtract the 8, you get 5x. You get x is negative 6. What's that? Now, here's the other thing. What's nice is that you guys all have a calculator. You could easily check these. You can easily check these, and I recommend doing so because there will be some of these that give you what's called an extraneous solution. It's a solution that looks like it's going to work, but it's not going to work. Especially when you have your variables within the denominator. Okay? Sometimes a solution might be a 0 of a denominator. And we all know you can't divide by 0, right?
Right.
Right. I would recommend that. So, just for example, I would do this once this loads. So, what was it? Alpha y equals 4 over negative 6 plus, what was it? 5 over 2?
5 over 2.
Thank you. Five over 2. And just hit enter.
Oh, because it was a negative.
Oh yeah, it'd be over negative 6. Yes, it'd be over negative 6, so that works out. Yep. So if you look at it here, it would be negative 11 over negative 6, so it works out, and you're fine. Okay. So it works. All right. Let's do another one. Don't look at all cross-eyed. It's letting you.
Can I like switch it so the 5x over x minus 2 is on the other side?
Then you have a side equal to 0.
No, like, just like you, like, write it the opposite way.
Oh, put the 7 first. 7 plus 10x and then equals the other. Yeah, that's fine. Yeah, that's fine. Yes, ma'am.
Would you multiply the 7 by x minus 2?
Yes.
Okay. Or you should just put the 7 with the 10.
No, you can't. The 7 doesn't have a denominator, or does it?
Yeah,
it does.
It's
It's
1. So what's our common denominator here?
X minus 2.
What are you going to multiply everything by?
X minus 2.
So you can multiply everything.
But you need to do that because the 7 doesn't have an x minus 2?
Correct.
Okay.
So if you multiply and distribute out the x minus 2 to everything, you wind up with 5x. When you do that, they drop out. So you don't have it.
We do a long way up.
Equals 7 times the x minus 2 plus 10.
Where are you?
He simplified. X minus 2, X minus 2.
Just like we did yesterday. That's all it is. Guys, I'm not writing this out long form. You have to understand that it's called the distributive property,
Oh, that's it.
and there's no reason for me to use the space. Okay? X times 5x over x minus 2. They drop out. This one doesn't have it. It needs it. This one has it. It doesn't need it. Just go. We're just multiplying through quickly. All right? These should be a lot faster than what we did yesterday. You're doing a little bit less work. Okay?
Wouldn't you get 5x squared?
No. No.
Oh, yeah, that, okay. Okay.
You're not distributing anything. There's no point.
I get
Okay?
it. I get it.
So now you have 5x equals 7x minus 14 plus 10. X equals 2. And what happens? I heard you say, it doesn't work. Why doesn't it work?
Because the denominators would be 0.
Your denominators would be 0, so this means that
It's
No.
it's a no solution. They call that, in this case, when you actually solve something, but that something doesn't work, it's called an extraneous solution.
Extraneous?
Extraneous.
You're extraneous.
What are you doing?
So you did it right, but it doesn't work.
Correct.
Okay.
It's the problem that has an answer, but it doesn't have an answer. Like, what is the meaning of life? There's an answer, but is it the answer?
No, there is
That's what I do.
only.
We should be in the humanities class right about now.
Oh, by the way,
All right, do this one. I'm gonna let you try this one on your own. Now, does everybody agree that my common denominator is gonna be x plus 1, x minus 1?
Yeah.
You're okay with that, right? So here's what I'm gonna do. When I'm writing these problems down, especially like in my homework and stuff, I'm gonna move it over a little bit, so if my little red line is going down like this, that way I have space to write in my common denominator on one side. It's just a little bit cleaner. Common denominator is gonna wind up being x plus 1, x minus 1. All right? I'm gonna do this one long form so you guys can see where these terms are going and why they drop out. All right? First one, you get x plus 1, x minus 1, 4x plus 1, all over x plus 1. Next one, you get 12, x plus 1, x minus 1, over x plus 1, x minus 1, plus 3, x plus 1, x minus 1, and there's no denominator. Okay? Now, at this point is when your denominators will all go away because you've multiplied both sides of the equation by the common denominator to make them vamos.
That's fun. Oh my goodness. I really got it.
That's why that was working for you. That's why that we could do that. That's why there's no reason for us to multiply all of this out, because all you're doing is like, what does this denominator already have? Well, I only have to multiply it by one part. Does it have both of them? That's all I'm doing.
Okay.
So now, I have to set this up and do some FOILing. We have 4x squared plus x minus 4x, so it's minus 3x minus 1 equals, well, this is x squared minus 1, so it's 3x squared minus 3 plus 12. Are we okay with that?
Yes.
All right. Set one side equal to 0, which means move everything from the right to the left. The reason I'm doing that is because the x squared term is greater over there. If it was the other way around, I'd go the other way. That's all. I want a positive x squared term. Let me scroll this up some. Subtract 3x squared, add the, well, this is what, 9? Subtract 9. So now we have x squared minus 3x minus 10 equals 0.
5 and 2, x minus 5.
Very good. Which gets you to a factoring problem to solve the zeros. So your two solutions to this problem, because it winds up being quadratic, are 5 and negative 2. But do they both work? So it's really easy to go back and look. Will 5 and 2 be all right?
Yeah.
Yeah. 5 and 2 are, or 5, excuse me, negative 2. They're both going to be okay. So you have to go through a whole rigmarole to get there, but it's not that bad.
I was just thinking, I didn't know what was going on.
I get really bored of
All right.
Not like it's 80 on it. Like really bad. Yeah, that was hard. But other than that,
Do one more. You got a minute or two.
yeah.
Nah. And one more to show, at least one more to show you. What do you do here?
Just times everything by x. No. Everything by x, right?
It looks bad.
No. X squared minus x.
Hold on. Wait, just wait.
Wait, what was the from 2 over x squared minus.
What do you do?
You,
Why do you cross multiply?
oh!
What's the reason why you can cross multiply here?
Oh, because it's.
Well, there's an equal sign here too, but it couldn't cross multiply because it's fraction equal fraction. In this case here, we have fraction equal fraction. There's nothing else tacked on. Whenever you have fraction equal fraction,
You can.
cross multiply.
And then the x is. Okay.
It's a nice little trick. All right. This is the example when you have fraction equal fraction. Since there's nothing else being tacked on, no plus 2 or minus 6 or anything like that, you can go ahead and cross multiply. In doing so, you wind up with 2 times the quantity x minus 1 equals x squared minus x. So 2x minus 2. Which way am I moving stuff, do you think? To that side, to the right side? So we have 0 is going to equal x squared. Subtract the 2x, so it'll be minus 3x plus 2. What times what's positive 2? You add together to get negative 3. Negative 2, negative 1. So that means our zeros are
1 and
2 and 1.
well, it's only 2 though.
But only 2.
And because 1 is an extraneous solution.
Wait, what's
Yes,
the
it's
extraneous
good.
solution?
It just took you a little bit longer, didn't it? Okay? So what happens here is it's a shortcut that you might have remembered from algebra, like a long time ago, when you're working with ratios and proportions. This is just a proportion. A proportion is 2 ratios or fractions that are set equal to each other. Since there's nothing else that's tacked on, you can go ahead and do that. Let's do this.
How about we do like 5?
I want to do on section 9.6, page 571. 28, 29. Okay? those. We'll do that grouping right there. Shouldn't be that bad. All right? Make sure you check for those extraneous solutions. Sometimes you have them, sometimes you don't, okay? If you wind up like the example we just did where you had the 2 and the -1 and 1 just didn't work, all you do is just cross one of them out. If both of them don't work, you just say no solution, okay? Yes, sir?
She's fine. She's just